Welcome to Number System series. In this lesson, we will explore the fundamentals of number systems, including types, properties, and applications. Whether you are a student, teacher, or just curious about math, this series is designed to help you understand the basics and build a strong foundation. In lesson 1, we will cover the basics of number systems, including decimal, binary, octal, hexadecimal, and sexadecimal. By the end of this lesson, you will have a solid understanding of the different types of number systems and how they are used in real-world applications. Let's get started and dive into the world of number systems. So, what is a number system? A number system is a way of representing numbers using a set of rules and symbols. It's like a language that helps us communicate and work with numbers. Think of it like this. Just like we use letters to form words, number system use digits like 0 to 9 to represent numbers. For example, we use A, B, C, D, and so on to form words, right? In the same way, we use digits 0 to 9 to form numbers. Okay. So, where does this number system help us? It helps us in counting and calculating, representing quantities and measurements, solve problems in maths, science, and everyday life. So, before knowing all these types of number system, we must know what are the basic key components of number system, right? So the basic key components of the number system are as follows: digits, base, place value, and face value. So let's break it down with example. What is a digit? A single symbol or numeral used to represent a number is called a digit. Example 0 to 9 in a decimal system. Let's take an example 4, 6, 5. In this, 4 is a digit, 6 is a digit, 5 is a digit, but this whole is a number. This whole is a number. So let's take another example. 3, 4, 8. In this whole is a number, but 3, 4, 8 is a digit. These all are a digit, but this whole is a number. Okay. Now let's understand what is a base. Base is the number of unique digits used in the system. Example, base 10 for decimal system. Here you can see, in decimal number system we use 0 to 9 digit, which is having total 10 as a base. Binary number system, this is having base 2. Octal number system, this uses base 8. Hexadecimal number system, this has base 16, and sexagesimal number system is having 60, 360 degree. This is used for time and angles. Okay. So these are the different types of number systems, which is having a base 10 for decimal number system. Binary number system have base 2. Octal number system is having base 8. Hexadecimal number system is having base 16, and sexagesimal number system is used for time and angles. So this is called as base. Now let's move on to the next, that is place value. The value of a digit depending on its position in a number is called a place value. For example, let's take 456. So in this, 4 is in the hundreds place. 4 is in hundreds place, so it is 400. 5 is in tens place, so it is called 50. 6 is in ones place, so it is 6. So adding all this, you will get 456. Okay, so it is nothing, just the value of each digit based on its position in the number. Understood? So next, understand what is face value. The face value is the actual value of a digit in a number, irrespective of its position or place in the number. It's the value of the digit itself. For example, let's take 341. The face value of 1 is 1. The face value of 4 is 4. The face value of 3 is 3. Let's take another example. 1861. The place value of 6 in this is 6. The place value of 8 is 8. Place value of 1 is 1. Okay. Place value of this one is also 1. So it's nothing, it's just the actual value of a digit in a number, irrespective of its position. So next, let's understand what are the different types of number system. Okay, so the first is decimal number system. This is having base 10. Why we use base 10 here? Because this contains digit 0 to 9. The decimal number system, also known as the base 10 system, is a number system that uses 10 distinct digits that are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This whole is a 10 in numbers, so we call the decimal number system as a base 10 number system. Let's understand this with an example. 456.78. Here 4 represents 400. 5 represents 5 tenths, that is 50. 6 represents 6 ones, that is 6. 7 represents 7 tenths, that is 0.7. 8 represents 8 hundredths, okay, that is 0.08. Understood? Now, why we call this as 100, whereas we call this as a hundredth? Because 0.78 is a fraction part, that is a decimal part, whereas 456 is a multiples. So in order to differentiate what is a decimal part, what is a whole number, 456, we call it as 4 as 4 hundredths, and this is we call as hundredth. Hundredth part, and this is hundreds, okay. This we call as 5 tenths. This is having 6 ones. This is having 7 tenths, okay. So this is a decimal number system which is having base 10, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now let's move on to the next, that is binary number system, which is having base 2. This uses 2 digits, that is 0 and 1. So it is called as base 2 number system. This system uses only 2 distinct digit, that is 0 and 1. It's used in computer language, computer programming, and so on. Let's take an example. The binary number 1010 can be broken down as follows. That is 1 into 2 to the power 3. This is 1 into 2 to the power 3. We are using 2 because it's a base 2. This is a binary number, so we are using base 2. 2 to the power 3. Why we are using 3? Because this is 1, 2, 3. 2 to the power 3 is equal to 1 into 8 is equal to 8. Now next is 0. 0 into 2 to the power 1 and 2. 1 and 2. So 2 to the power 2 is equal to 0 into 4 is equal to 0. Next is 1 into 2 to the power 1 is equal to 1 into 2 is equal to 2. Next is 0. 0 into 2 to the power, nothing is there to the right. 0 is equal to 0 into 1 is equal to 0. So adding all this, 8 plus 0 plus 2 plus 0, we get 10. So this is the decimal number for the binary number 1010. This example illustrates how binary number work using a base 2 system to represent quantities. Understood? So next, let's understand what is octal number system. The octal number system is a base 8 number system that uses 8 distinct digits, that is 0, 1, 2, 3, 4, 5, 6 and 7. Since it uses 8 numbers, so it is called the octal number system. It is used for computer programming and file permissions like Unix and Linux. In networking we use this. Now let's understand this with an example. Let's convert an octal number 123 as an octal number. Now 1 into, since it's an octal number, we will multiply this with an 8 and to the power 1 2 is equal to 1 into 64 is equal to 64. Next is 2. 2 into 8 to the power, only 3 is there. So 1 is equal to 2 into 8 is equal to 16. Now next is 3. 3 into 8 to the power 0 is equal to 3 into 1 is equal to 3. Adding all this, 64 plus 16 plus 3 is equal to, we get 83. So this is the decimal number for the octal number 123. This example illustrates how octal number work using a base 8 system to represent quantities. So next, let's understand what is hexadecimal number system. A hexadecimal number system is with a base of 16. It uses 16 digits, that is 0 to 9 and A to F. 0 to 9 is same as decimal and A to F is representing 10 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for 10, we uses A, that is 10. For B, we use, for 11 we use B. For 12, we use C. For 13, we use D. For 14, we use E. And for 15, we use F. So this is the hexadecimal number system, since it is using 16 digits, 16 numbers. Okay, 9 digits and A, B, C, D, E and F. So let's take an example. Let's take example 1A2. So here 1 into 16 to the power 2. Why 2? This is because this 1 2 2 is equal to 1 into 256 is equal to 256. Next is A. What we call A is a 10. So 10 into 16 to the power 1. 16 to the power 1, only 2 is there after A. So 16 to the power 1 is equal to 10 into 16 is equal to 160. Next is 2. 2 into 16 to the power 0 is equal to 2 into 1 is equal to 2. So adding all this we get 256 plus 160 plus 2 is equal to 418. So we get 418 as a decimal number for hexadecimal number 182. Right? So this example illustrates how hexadecimal number works using a base 16 to represent quantities often used in programming and computer science. Now the next is hexadecimal number system. The hexadecimal system is a base 16 number system that originated in ancient Babylon. It's still used today for measuring time and angles. It is used for time, which is having 60 seconds, right, in 1 minute, and 60 minutes is equal to 1 hour. Next is angles. Here 360 degree in a circle with each degree divided into 60 minutes. That is, each degree, that is 1 degree, is equal to 60 minutes, and each minute further divided into 60 seconds. That is, 1 minute is equal to 60 seconds. So this system is useful for calculations involving time and angles. Okay, and that's all. That's a wrap. We have covered the key components of a number system, including digits, base, place value, and face value. We have also explored various types of number system, such as decimal number system, which is having base 10, binary number system, which is having base 2, octal number system, which is having base 8, hexadecimal number system, which is having base 16, and sexagesimal number system, which is used for time and angles. Right? I hope this video has given you a solid understanding of the number system and their significance in mathematics and computer science. Thanks for watching, and don't forget to like and subscribe for more educational videos. Thank you.